Okay, we're still in the mechanical engineering section of the technology portion of this course, and one of the subtopics in mechanical engineering is the use of various passive mechanical components, or what we might call machine elements. And I have a few slides here to give an overview of some of those machine elements or components that exist. You're probably familiar with many of these already, so in many ways this is just a bit of a summary. The first topic is the use of shafts. So you can see a shaft down there in the lower left-hand corner in the animation. And the shaft is used to transmit rotational power throughout a device. Presumably it's hooked up to some sort of actuator, like perhaps a motor. And we attach various things to the shaft, like wheels or pulleys, in order to pick off the power and to do work throughout our device. As we do this, the shaft is loaded with torques, external torques and forces, and as a result, stresses build up within the shaft. And one of the areas of mechanical engineering analysis that we don't go into in terms of this course, but which certainly exists, is an analysis of the stress and strain within the shaft, and decisions like, is the shaft too long, is it supported properly, material choice, the diameter of the shaft, things like that. Those are design choices that come into play through by virtue of analysis of the stresses that arise in the shaft. As we place various devices along the shaft, we need to somehow attach them, and so there are various other devices that interact with the shaft, like shaft collars, in order to place certain devices laterally along the shaft, like wheels or cogs. Sometimes the shaft is slotted, as you see in the lower left-hand corner of the animation, which is allows us to exploit the slot to put a little shaft key in there in order to help transmit torque from the shaft to the wheel. You might even take two shafts and connect them end-to-end through the use of a shaft coupling or something else like that. So the notion of shafts and couplings and things you attach to shafts is one of the basic features we see in many products. May also be familiar with the notion of a gear. You can see here a gear, a rotating component, typically has some sort of teeth or cogs along the outer circumference. Those mesh with other gears or racks or other devices to allow you to transmit motion between the two without slip, also transmit torque. By doing this, we usually use it to achieve mechanical advantage, and in doing so it can also allow us to convert from rotational to translational motion. You can see a bunch of different types of gears and geometries in the animations down at the bottom. That includes, on the far right, a rack and pinion arrangement, which is, as you can see, a way to convert between rotational to translational motion. We have things called transmissions. The point of a transmission is to change the location or direction of a torque axis. In doing so, it's very typical to also incorporate mechanical advantage into the design of the transmission, although that's not necessary. And remember that mechanical advantage allows us to amplify the torque or the speed, one or the other, in order to be exploited for the purposes within our device. And recall that if you do amplify one, you are going to cut the other. Friction oftentimes arises in our devices, and bearings are used in many cases to reduce the friction between sliding parts. In doing so, it helps to constrain the motion. A couple different kinds of bearings are very typical. Ones you think you're probably familiar with already. The first being a rotary bearing. That would be the kind of thing that you might use for spinning a wheel about an axle. Another is a thrust bearing. That would be useful in a chair or a bar stool and accommodates axial loading. You're probably also familiar with linear bearings, so allowing slides laterally along a shaft. Certainly in machine tools, 3D printers, things like that, we have linear bearings to hold the print head as it moves laterally back and forth along a shaft to position itself. A lot of other ways, apart from the use of bearings, to reduce friction. So it could be the choice of materials that have low friction surfaces. use of fluids and lubricants, use of magnetic fields to separate parts, and so on and so forth. Also associated with shafts are various versions of things that can be attached to the shaft, or variations in the design of the shaft, things like cranks and cams. And so in the lower left-hand corner, you see an example of two cams that have been attached to a rotating shaft. The cams themselves are these sort of eccentric wheels that are shaped very specifically to provide you the kind of motion that you're looking for. You can see they interact, in this case, with two rods, push pins or pistons, and as the cam rotates with the shaft, it moves the piston vertically up and down. It certainly pushes it down. What isn't shown here, presumably, is maybe some sort of spring return that would push the pin back up. And you can use this to do all sorts of tasks. A very common one is when you push the piston down, it opens a valve, as an example, in an engine. Cranks are radial extensions to shafts, and usually they're associated with the use of a connecting rod that then allows the rotational motion of the shaft to be converted into linear motion. And you can see a version of that there with the crank and slide mechanism, the second animation from the left. You can also see what's known as a crankshaft, where the shaft itself has radial bends in it as it goes from one end of the shaft to the other, with rods, connecting rods, connected along those bends in order to move the pistons back and forth. And on the far right, just an example of a completely different kind of kinematic arrangement. We have what's known as a slotted link mechanism that shows the conversion of rotational motion to linear motion, or vice versa. And there are many, many other sorts of designs and very clever arrangements, kinematic arrangements of devices that allow this conversion. A lot of other things that go into the mechanical engineering of our systems. Certainly we build frames in order to hold various components inside our devices at certain locations. When we do that, we use fasteners. As you can imagine, a lot of times hinges are used to allow rotation along one axis so we can accommodate doors and lids. Oftentimes those doors and lids are closed and held in place with the use of latches. We might use a piston to hold a lid up so that it stays there, and yet makes it fairly easy to push it back down when the time comes. We use springs in a whole variety of ways. Oftentimes, I mentioned previously, we might use a spring at the bottom of one of those pistons and associated with a camshaft in order to provide the return force. You'll see seals throughout your devices, especially when you deal with liquids or lubricants as well. And depending upon the kind of task you're trying to do with your device, you might see the incorporation of various types of sensors, particularly when you want to read off and display the value of those sensors, or possibly even use those sensors in a feedback control loop. Our most basic sensors with respect to the use of motors and motion would be position and velocity sensors. Just a few of the many, many different options that exist are shown or listed here. You might imagine a potentiometer. We've used them in class. You can manually turn the shaft in order to change the resistance, put that into the top half of voltage divider, and therefore shaft change is converted to a changing voltage, which we can then think about and compute with respect to in our circuitry in our computers. So you can imagine the use of potentiometer, and rather than a manual rotation, maybe it's hooked up to some sort of gear train or transmission in order to link the rotation of the potentiometer to motion of the device. There are other things called encoders, and they can be used for position or velocity control or sensing. You can see the graphics at the bottom sort of showcasing a little bit about encoders, and the lower left portion is an encoder device itself, and it shows sort of an optical mask, which is that disc with all the little white dots on it. The dots imply a hole or a transparent portion of the disc so light can shine through. And you can see an LED on the top shining on the disc and therefore allowing light to go through it based on where the transparent holes are. And then there's a pattern there at the bottom. The pattern presumably is read by some sort of detector or a series of detectors. And based on what pattern is seen, you can get various information about the position or velocity of the device. 3 of those optical masks are shown there to the right. The first one on the left would be used for direction of travel and speed sensing. And then the 2 on the right would be used for position sensing. And the 2 on the right, sort of very interesting arrangements, almost artistic in some way. Those are actually 2 different kinds of binary patterns. The left one, or the mask in the very middle, that's actually a standard binary pattern. So that geometrically reflects the way we would count in binary using normal binary code. The one on the right is a slightly different version I mentioned briefly in class called gray code, which is another binary code. Again, it's binary in the sense it uses ones and zeros, but it's not a standard number system. And so if you compare it to standard binary, the sequencing of the ones and zeros occurs in a different order in order to convey information about the count. And the reason it does that is it gives you tolerance for things like mechanical misalignment in the mask and some other interesting properties. We'll follow up on that topic in class. So these past few slides really have just been to give you a sense of some of these other machine elements that are going to exist in various ways in the devices and products and systems that we'll be building in this class and that you'll see as you interact with various things in the world.